Hello. On this video, we're going to be discussing long division of polynomials and synthetic division of polynomials. We're going to compare the two, and obviously synthetic's going to be way better. Check it out. Let's begin with long division. So once again, we're going to go way back to elementary school, and we're going to divide 157,598 divided by 21. Whatever is first on your division problem, that's going to go inside the division box. And of course, the 21, the second item, is going to go outside of the division box. That's your divisor. You're dividing by 21. You're dividing by 21 over here. And of course, you don't think, how many times will 21 go into 157,598? You don't do that. What you do, that doesn't sound good. What you do is 21, how many times will it go into 157? And even easier, you could just look at that first digit 2 and think, how many times will 2 go into 15 without going over? That'd be a 7. So we're going to put a 7 right above over here. And 21 times 7, you could think of it like distributive property, where you say 7 times 1 is 7, and 7 times 2 is 14. So we are subtracting. Now, something that we did not do in elementary that I want you to practice right now is putting it in parentheses with the minus sign out here, okay? Normally in elementary school, we just put a minus. But anyways, 7 take away 7 is 0, okay? 5 take away 4 is 1. And 1 take away 1 is nothing. So we have a 10 right here. What do we do next? You take that next digit and bring it down. So we now have a 5 down here, and that looks like 105. 105. So how many times will 21 go into 105? Or even easier, you could think 2 times what will get us close to that 10 without going over? That is a 5. Okay. And again, distributive property, 5 times 1 is 5. Put that 5 right there. 5 times 2 is 10. Put that 10 right there. And of course, we are subtracting, so put in parentheses with the subtraction sign. The only reason I'm doing the parentheses is because it will help you a lot when we get to polynomials, division of polynomials. And then we're going to subtract 105, take away 105 is 0. So there's nothing left. And of course, what do we do next? We bring down this 9. Just bring it right down. It's going to be a 9 right here. And of course, how many times will 21 go into the number 9? It doesn't work. I mean, it won't go in 0 times, so let's put a 0 up here. And let's finally bring down that 8. Okay, we're going to take this 8 and bring it down. That'll be a 98. So 21, how many times will it go into 98? The end, without going over. You could just think, how many times will 2 go into 9 without going over? That will be a 4. So let's put a 4 up here. And again, it's like distributive property. 4 times 1 is 4. 4 times 2 is 8. And we are subtracting. So 8 take away 4 is 4. 9 take away 8 is 1. So the remainder is 14. Now, what did we do in elementary school when we had a remainder? We would simply put the remainder, well, sometimes we'd put an R and then 14, right? But we're not going to do that. Now, we're going to actually write it, the remainder over the original divisor. So you're going to have a fraction, and the original, or the remainder is 14. You put that as a numerator. And the divisor is 21. Put that as a denominator. So your answer is this right here, 7,504 and 14/21, which that sounds weird because it could be reduced, and we have to reduce. Always make any answer as simple as possible. Always simplify. So we have 7,504. If we divide both top and bottom by 7, we will get and 2/3. So there's your answer. That took a while. Yep, but it's good to review. That way, when we get to polynomials, it will make more sense. So here's a question that you're going to see on the practice test, and it could be done two ways, with long division and then or with synthetic division, which obviously I prefer synthetic, but let's go with long division first. So I'm going to take this first polynomial, and first of all, it's not in standard form. You need it to have the highest exponent down to the smallest. So obviously, this negative x is out of place. It should be between the 2x to the third and the 25. So let's actually write that inside the divisor. So here's my divisor. It should be 2x to the third And then notice that there is no x squared term. So that's the first thing that you want to do with the long division or synthetic. You want to represent every single power. All right, so every term you want to put in order from the highest exponent down to the smallest, down to the constant. But you want to have every power represented. So if your degree is 3, that means the highest exponent is 3. Then you got to have the power of 2, then the power of 1, which is here, and then the constant at the very end. Now notice that there is no x squared, so we're going to fill that in with a plus 0x squared. That means that there is no x squared, right? And then, of course, after that, we have the negative x. So let's put that negative x right in there, minus x. And then we have the plus 25, plus 25. So there is my first polynomial in standard form, highest exponent, 3, down to the smallest, 2, 1, constant at the very end, no variable, right? So you have to have every single one represented, every single power, 3, 2, 1, constant at the very end. And then we're going to divide it by x, the binomial x plus 3. We're going to divide it by the binomial x plus 3. And again, just like back in elementary school, we didn't think of 158,000 something divided by 21. We didn't do that. We just focused in on the first terms, right? So 2x to the third and x. X times what will get us this 2x to the third, right? So x times 2x squared will get us 2x to the third. So let's put that 2x squared right above the other x squared term. You want to stay totally organized. X squares on top of x squares, x's on top of x's, numbers on top of numbers, right? Constant on top of constants, right? So we have 2x squared, and let's distribute 2x squared times 3 is 6x squared, which we're going to write right below the 0x squared. So 6x squared right there. And then 2x squared times x is 2x to the third. 2x to the third, that was a positive 6x squared. And we are subtracting, so let's put this in parentheses with the minus sign. So right here, it's very, very important that we use those parentheses, because that's the only way we're going to remember to distribute this minus sign. If you didn't put the parentheses, yeah, you could probably subtract this, but you might forget to change this to a negative 6x squared. See that negative sign? It actually changes the sign in front of the 2 and in front of the 6. So what you really have is 0x squared, take away 6x squared. That'll give you a negative 6x squared, okay? And then, of course, you have a negative 2x to the third with a positive 2x to the third. When you combine that, that ends up being nothing. So you could put a 0 there, you could just leave it blank. What do we do next? We get this next term, the negative x, and bring it down. So we will have a negative x right here. And now we think x times what will get us this negative 6x squared? That will be a negative 6x. And notice that I wrote the negative 6x right on top of the other x term, which is on top of the other x term. You want to stay organized. X is on top of x's, x squares on top of x squares, x cubed on top of x cubed, so on and so on. All right, so let's distribute now. We have the negative 6x times 3. That'll give us a negative 18x. And we're going to write that down, negative 18x, right below the other x term. And then negative 6x times positive 6x, that'll be a negative 6x squared. And that's what we wanted. We wanted the identical value to be able to cancel out when we subtract. So again, we are going to subtract here, which does change those signs to positive, right? This is going to make that a positive 6x squared, which will cancel. This is going to make it a positive 18x. So a positive 18x minus x, that's positive 17x. Again, this minus sign changes that to a plus, changes that to a plus, and we end up with a positive 17x. Last but not least, drop down the 25. So it's going to be a plus 25. Finally, again, x times what will get us this 17x? Well, obviously, it's going to be a positive 17. And again, distributing 17 times 3, or you could even go backwards. 17 times x is that 17x that we wanted. And 17 times 3, 10 times 3 is 30, 7 times 3 is 21, so that's 51. So we get a positive 51. Now again, remember that we are subtracting. So that would change that to a negative 17, which would cause it to cancel, and that would change this to a negative 51. So imagine that. You have a positive 25 and a negative 51. That will give you the remainder of negative 26. So what is our answer going to be? It's going to be this polynomial with this remainder, negative 26, over the original x plus 3. And the negative, it doesn't have to stay on the 26. When you make the fraction 26 over x plus 3, you can put the minus sign in front of the fraction. Let me show you what I'm talking about. Let's go over here to the answers. Well, I guess looking at these multiple choice answers, we're not able to find the actual answer. I mean, we have the 2x squared minus 6x plus 17. That's all there, but the remainder is wrong. It should have been minus 26 over x plus 3. So again, to show you the way the correct answer should be written, here it is. This is your answer. 2x squared minus 6x plus 17 minus 26 over the original divisor, x plus 3. That took a long time. Let's check this same exact question out with synthetic division. I apologize, I didn't fill in the correct answer. None of these, right? This one right here, that's what messed it up. Everything was perfect except for that remainder 17. Should have been negative 26. All right, so let's do the same problem but with synthetic division. Same concept. You want to have every single power represented. You want it in standard form. But when we do synthetic division, we do a little box like this. Okay, now, or a reverse L, whatever you want to call it. And what value belongs in here, it's taking this divisor, the binomial, setting it equal to 0 and solving. So if you did do that and thought x plus 3 set equal to 0 and solved, x would equal negative 3. And that's exactly what we plug in right here, a negative 3. Okay? Now, we need a list of numbers over here for synthetic division, and it has to come from the coefficients of every single term in your polynomial that's in standard form, representing every single power from highest down to smallest down to the constant. Okay? So what do we really have here? The highest power is 3, the degree is 3. So that leading coefficient is really 2, and you're going to write that 2 first. So you're going to have the 2 right here. And then, where's the x squared? There is no x squared, so you're going to represent that there is no x squared with the 0. And then, what's the coefficient of x? That's a negative 1. So there's a negative 1 in front of the coefficient of x. And last but not least, the constant 25. Here's a constant 25. This is how to set up synthetic division. Okay, now I hope we remember that in synthetic division, as you come down, you combine. So 2 plus, what number's right here? There is no number. So 2 plus nothing is 2. And then as you go up, you multiply. Negative 3 times 2, that'll give us a negative 6. As you go down, you combine. 0 minus 6 is negative 6. As you go up, you multiply. Negative 3 times negative 6 is positive 18. As you go down, you combine. Negative 1 and 18 is 17. As you go up, you multiply. Negative 3 times 17, and I want to do this one in green, is 51. That's negative. And then we put a little line right here. And whatever we get from here, that's going to be our remainder. Okay? So when we say 25, take away 51, that'll be a negative 26. So the remainder is negative 26. So here's our answer, but this is our remainder. Now, keep in mind that if you started with the highest degree 3, x to the third, and you're dividing by x, if you just think about that, x to the third divided by x, that answer should be an x squared. So this is what we call a depressed polynomial, and this first term should be with an x squared because we brought it down from a third degree down to a second degree. And the reason for that is because x to the third divided by x is x squared. So my answer will be the 2 with an x squared on it, the minus 6 with an x, and the plus 17, and the remainder minus 26. Now notice that I put the minus in front of this fraction over the original divisor, x plus 3, x plus 3. And as previously mentioned, none of these are correct. It looked like this one was going to be it, but that's not the right remainder. Should have been a minus 26 over x plus 3. Again, if you're watching this part of the video, the synthetic division part, and if you wanted to watch the long division part, just rewind this specific video to watch the long division part to see what you prefer to use.